Hello, and welcome back to the MCAT grind. Today we'll be doing Organic Chem, Chapter 1, Nomenclature. So, in regards to nomenclature, is naming. It is present in pretty much all of the questions. So don't be deceived by its low percentage yield. It is pretty much everywhere. Whenever you see a new compound, you will use nomenclature when doing a question. So, starting with functional groups. These are groups that you will see on the chain or whatever compound you will see, and they're listed in highest priority to the least priority. And we also have the steps to name a compound, and it is in the order of different steps, and using these functional groups to determine which one would be our naming for our main name. So, let's go over the naming steps first. So when you see a compound, you want to identify the chain, the longest chain with the priority group. Now, what I mean is, if you have a compound that goes like this, right? Now we see that there's OH, which denotes an alcohol. That chain goes 1, 2, 3, 4, 5, 5 long. However, this chain of just carbon is 1, 2, 3, 4, 5, 6, 6 long. However, we still choose the 5 with the alcohol because alcohol is of higher priority. So that's the longest chain possible with alcohol. Next, we want to number the chain with the priority group as low as possible. So we will use OH and note it down as 1. Number 1 for our priority, for our group. 2 for this. 3, 4, 5. That's our chain. Next, we want to number the substituents as low as possible. Aside from this chain, the only substituent we have here is 1, 2, and alkane, ethane, because there's 2 carbons. So we want to number this whole group as 1, 2. It's on the second carbon, so it's a 2 ethane. 2 ethane. 2 ethyl, because that is its prefix. Next, we want to combine in alphabetical order. Because our main chain uses alcohol, we will use alcohol as a suffix. So 1, 2, 3, 4, 5, that uses 5. So that's a propanol. Right, the whole big chain is propanol, and we have our 2 ethyl here. So what does that mean? We will combine 2 ethyl, propanol. There we go. That's our whole name, and we have to combine in alphabetical order, and since we only have 1 substituent group, that's no problem. We also need to put commas between the numbers. If we have 2 ethyl groups, then if there's 1 here, 2, and 4, we need to put a comma between 2 and 4. We also need to put a dash between the number, right, 2, and the words, so ethyl. Alright, so let's go through the functional groups together. The first functional group we have is carboxylic acid. It is denoted by a carbonyl group, O double bond to C, and this is bonded to an alcohol. So the whole thing is a carboxylic acid. You would find the general trend towards a higher priority group is the one that's more oxidized. So carboxylic acid all the way up, whereas alkane is the least oxidized, so all the way down. The prefix for it is carboxy, right? Carboxylic acid, carboxy. And the suffix is oic acid because it's at the end, oic acid. Anhydride is really just carboxylic acid, but An means taken away, hydride. So taken away a hydrogen, not a hydrogen, a water group. So putting these two together against each other, carboxylic acid with another carboxylic acid. If you were to join them at the OH part, the alcohol part, you take away the H2O, and then you're left with an anhydride shape. The prefix for it is quite long, is alkanoloxy or carbonyl. You'll probably see carbonyl more often, as I find. Alkanoloxy would sometimes be in older passages. Carbonyl will come up more often because it really just is the carbonyl group that you're referring to. And the suffix is anhydride. You don't put a dash to it, you put it as a separate word, anhydride. Next we have the ester group. The ester group you see is just bonded to a C after O. It really is just an ether group with a carbonyl to one of the C's. And the whole prefix for it is alkoxycarbonyl. So it is a carbonyl group along with an alkane and an oxygen. You can break it down. Carbonyl bonded to an oxy group, and which is bonded to an alkyl. So that the suffix is O8. Ester O8. Next we have amide. Amide is like carboxylic acid, except for the OH is substituted with an NH3. So it is just like an amine bonded to an NH3, but with a carbonyl group. So the prefix is carbonyl. Think M for amine, the nitrogen there, right? So carbo for carbonyl group combined with the amino group, or combined with the NH3 group. So we have carbonyl, and the suffix is amide. For aldehyde is a lot more simple. It's just a carbonyl group with the C bonded to just an H. So no excess extraneous groups bonded to it. Aldehyde, and the prefix is oxo. The suffix is al. Aldehyde, al. Ketone, instead of the H, is covalently bonded to another C, which can be denoted as oxo or keto. More often, you will find it as keto to distinguish between ketone and aldehyde. The suffix is on, as in ketone. Next, we have alcohol. Alcohol is just bonded to OH. Prefix, we have hydroxyl, and the suffix, we have ol, alcohol. Next, we have alkene. Alkene is double bonded C to each other, and the prefix is alkenyl. Alkenyl. So, depending on the type of alkene it is, whether it is propane, ethane, ethene, or propene, ethene, methane, all the different kinds of chains it is. So if you have 6 or 7 heptane, and if it's heptene, you have heptanyl, and the suffix would be heptene. So it depends on which how many numbers you have in that alkene chain. Next, we have alkyne, which is triple bonded C to each other. Prefix is alkenyl, and the suffix is -ine. Alkyne, Y-I-N-E. Lastly, we have alkane for alkyl group for a prefix and ane. Simple as that. Next, we have special alkyls as substituent groups. T-butyl is isomers of butyl. You took the 1, 2, 3, 4. You took 2 and bonded to the first substituent. Neopentyl is of 5, 1, 2, 3, 4, 5. and it's just like t-butyl but extended more. Neo means new. Isopropyl, 1, 2, 3, instead of bonding to the end, you bond to the middle carbon. Sec-butyl, 1, 2, 3, 4, 1, 2, 3, 4. There are 4 carbon chains you're bonded to, but you're not bonded to the one at the very tip. You're bonded to the second one. Notice how it doesn't matter if you bond to the second one or the one here because it'll look the same. Isobutyl, 1, 2, 3, 1, 2, 3, 4. You're bonded to 4 carbons, but just like isopropyl, you're not binded to the very tip. You're binded to the middle. See, this one is binded to one in the middle. It's in like a windmill shape. All right, that's it for nomenclature. Be sure to know these very well because they will come up in all the compounds and reaction you will be doing in the future. Take care.